I started our discussion of inheritance mentioning that sometimes it can go bad. And the reason I did that is because I want you to not fall into this habit of, I now know about inheritance and I must see it everywhere. Everything must be inheritance, because it's not. When people do that, that's what gives inheritance a bad name. But there is an alternative to inheritance called delegation that often is more appropriate. It often fits the bill more, and it's kind of takes advantage of inheritance and interfaces in a way that's not quite so heavy-handed. So let's take a look at how delegation plays out. So one of the things I want to say is that in languages like Java, everything is an object. So whether you're dealing with the animal hierarchy we talked about before, or employees, or in some sort of business objects, or the stuff built in like collections and lists and sets, or even the objects itself. The class is an object. The pieces of a class is an object. Constructors and methods and fields, functions, attributes, all of it can be an object inside a programming language. And that becomes crazy when you think about it, that every class is related to each other and has those things. Now, this is how, in like a programming language like Java, you get behaviors like toString or equals or something like that. There's a convenience to that sometimes it's both true and not very helpful. So you can say like all mass, all matter in the universe is made up of atoms, and so everything's related, but it doesn't really help you practically for anything. So it's easier for the most part to think of things as distinct, and that's part of the problem when you overuse inheritance. So the idea of delegation is recognizing the fact that even though things are largely the same, often I don't need to have full objects that are variable from that, but just simply parts. So I know this probably isn't totally true, but in theory, I could have a car be entirely the same, but just swap out its engine between an electric engine and a internal combustion engine. The all the rest of the car, within reason, could theoretically function the same. Now, again, in a complicated system like an automobile, there's probably a lot of compromises you make. You move things around because you need a place to put the battery. The battery doesn't fit in the gas tank the same way because battery shapes are different and whatnot. But again, in principle, there are, especially in software, cases where I can totally just swap out one piece and account for all the variation I want to. So I could, instead of creating an inheritance hierarchy, I could create a class, which is the vehicle, the example we talked about before with VIN, color, horsepower, and drive, and then just simply have an engine that goes along with it. And when I want to do things like refill, I don't refill the vehicle, I refill the engine, if you will. And so the engine might have horsepower and go and have a totally separate, I could actually have another component that talks about the fuel system or something like that. And so the idea behind delegation is when I have something that's really, really, really complex, instead of having the whole complex thing be inherited and have multiple versions of that, where all the children could vary all of my function in well-intended but complicated ways, I just simply carve out this one little piece, which is the engine. So instead of a whole different car, I just have the same car with a bunch of different engines. Now, the misconception that some people will overdo is to say like, well, if you use delegation, you never need inheritance again. And that's not really true, because really going to delegation doesn't eliminate inheritance. You often are delegating the stuff to something else that ideally is replaceable. Um, you know, so it means that I need that replaceability has to either be inheritance or an interface on its own. So the great part, as I said, is delegation minimizes the moving parts, what might change. The idea is just to have that tiny little bit change. So when I have that part that's the engine, I say to that engine, go, the engine rolls forward or whatnot. But I did, just because I have the engine saying go, it doesn't change the whole way everything else drives. I still have my gear system separately. The engine doesn't determine whether it goes forward or backwards. It doesn't determine whether I turn left or right. It doesn't determine whether I go slow or fast per se. I just say go with some amount of force to it. But there's other things that I might govern with that. I could be out of gear, right? I could be in first gear, second gear, third gear, fourth gear. The engine just simply turns and does its job. So that is the notion of delegation, is to allow that customization, that allow that the changing of an object without having to have an entirely new separate object and all these child classes within that whole level of complexity. So again, I want you to be aware of it. Again, it's not something that you're going to use all the time, but it is something that's really, really helpful, even when you don't have inheritance sometimes, because sometimes you just want to delegate work to another object just to keep your classes small. But particularly when you want replaceability, it's really, really helpful for as an alternative to full-on inheritance structures or interfaces.